from a moving vehicle is lower when the vehicle is farther and louder when it is near. But have you ever wondered why? Let's find out in this experiment.
To demonstrate the change in pitch of sound at different points relative to the source, we prepared 3 recorders. Observer A, placed at the near front, Observer B, at the far back, and Observer C, moving with the vehicle. As the moving vehicle sounds its horns, the resulting sounds were recorded for each point. Now, let us listen to each recording.
Do you hear the difference? Well, in physics, this phenomenon is called the Doppler effect. This happened because as a wave, sound travel and spread out evenly in all direction in a stationary source. But in a moving source, the frequency of the sound wave differ in each point of observation.
To better understand this concept, let us look into a disturbance caused by a rock falling into water. A rock causes a disturbance to the water surface, also called as ripples. As we have learned in our biophysics lecture, waves exhibit compression and rarefaction. Sound itself is compression and rarefaction in the air molecules, detectable by vibrations in our ears.
Now, the number of vibrations per second is referred to as the object's frequencies, which can be measured through hertz. Subjectively, we can measure the pitch by the number of vibrations that reach the ear per second. That is, the more vibration results to higher pitch sound, whilst the lesser vibration results to lower pitch sound.
In the experiment, from the point of the observer moving with the vehicle, sound waves spread out evenly in all directions. Thus, we hear a relatively steady pitch due to the acceleration of the vehicle being the same with the observer. But for observers at the front and the back of the moving vehicle, the behavior of sound waves changes, which results to higher or lower pitch. Can you guess which is which? The Doppler effect is a change in frequency of sound waves when the source of sound is moving relative to a stationary listener. As the vehicle approaches observer A, the forward movement causes the sound waves to become compressed. Sound waves who are closer together have a higher frequency, resulting to a higher pitch. Similarly, as the vehicle moves farther from observer B, sound waves also spread apart, decreasing the frequency and in turn results to a lower pitch.
To summarize our learnings in this experiment, let us look at these points.
The sound as a wave exhibit compressions and rarefactions in the air, detectable by the vibrations in our ears.
Vibrations per second is called frequency, and frequency is directly proportional to pitch. In Doppler effect, there is a change in sound waves when a source of sound is moving relative to a stationary observer.
As a source of sound waves approach an observer, the sound waves get compressed, increasing the frequency and pitch of the sound. As the sound waves get farther from an observer, sound waves spread apart, decreasing the frequency and pitch of the sound.
Have you learned something from our experiment for today? That's great! The next time you hear a difference in the pitch of sound of a moving vehicle as it approaches and goes past you, you know that this is because of the Doppler effect. Thanks for listening!